Hello everyone, my name is Akhil Chauhan and this is the video lecture for COA, and the topic is General Register Organization. So it is a type of CPU organization, like we have single accumulator, general register and stack organization. So we are going to discuss General Register Organization today. It is used for 2 address or 3 address instructions, and let's first of all see its important components of CPU. We have first one, storage components, registers, or we also have flip-flops. Execution component, we have ALU, and under transfer components we have bus, and under control component we have control unit. So let's see its here we have mode, opcode, and destination operand, source operand, and another source operand. For example, let's say A and B, and it will be transferred to destination, and this whole part is called operand. So let's take an instruction x equals to a plus b into c plus d. So in 3 address we can do this by add r1 and ab. So a plus b will be transferred to r1, and again we can take add r2 cd. C plus d will be transferred to r2, and then we have multiply x1 will be the where the r1 into r2 will be stored. So now let's see under it in 2 address. In 2 address we use move. So first of all we'll move a to r1, and then we move, and then we can directly add b to r1, b plus r1, then store it in r1 similarly, and we can do this by with 2 address. Now let's see its diagram. Here we have 7 registers, and those are connected to 2 multiplexer, and then we have 3 selection line for each of them, selection A, selection B, and then we have A bus and B bus that is going to LU, and here we have operation code. The output is then again going to these 7 registers, and then we have 3 by 8 decoder. Here the decoder does is it selects which register is going to be selected, which we will see in the later part. So here we have 7 load lines, and here we have selection D for decoder. Now let's see the control word part. We have selection A, selection B, selection D, and operation code, which is of 5 bit, as you can see in the diagram here. So we have 3 for selection A, 3 for selection B, and 3 for selection D. What this table shows is how the encoding of register selects the line, like which is going to be selected. So here we have 000, that is input, and it's none, and similarly 001 r1 register r1 will be selected from register r1 will be selected here, and similarly for 012 r2 will be selected, and for so on for 111 r7 will be selected. Now let's see the encoding, how the encoding of ALU operation works. Here we have operation, which is of 5 bit, OPR, which is of 5 bit, and we have operation and the symbol that is used. For 000 we have transfer A, and its symbol is TSFA. For 00001 we have increment A, INCA, and similarly we have add A plus B, symbol is add, subtract A minus B, symbol is subtract, decrement A, decrement DECA, and A and B, and OR A and B, symbol is OR. For XOR we have A XOR. For complement we have COM and then operand. For shift right A we have SHR, the operand sign, and for shift left A we have SHLI. So thank you. That's it for this lecture.